This is part C of the tutorial, which demonstrates IBM pattern-based process model accelerators. In this part of the tutorial, we show you in more detail how the Control Flow Analysis plugin can detect and locate control flow errors in your process model, and how the accelerators can help you quickly correct the errors. On the canvas here is the Evaluate Candidate process. You may remember that in Part A and B of our tutorial, we have looked at the processes that issue a contract to the future employee and handle the contract once it has been signed. Now, this Evaluate Candidate process takes us back to the beginning to see what the applicant had gone through during the evaluation process. In this case, the applicant is applying for an internship or researcher position. The Evaluate Candidate process was created using traditional process modeling techniques by dragging and dropping individual modeling elements onto the canvas. Patterns, transformations, and refactoring operations were not used. The process model currently contains two common modeling errors. But first, let us look at what the Evaluate Candidate process does. The first part of the process receives the application, checks the curriculum vitae, and reviews different aspects of the application, including selected publications, qualifications, and grades and certificates of the applicant. Notice that the three tasks are on parallel branches opened up by a fork and subsequently synchronized by a merge. The second part of the process contains three decisions. If the candidate looks promising, we send him an exercise to test his technical and collaboration skills. If the candidate worked well on the exercise, an interview is granted. If the interview also went well, the candidate is accepted. In all the other cases, the candidate is rejected. Notice that all the no branches enter the reject task at the end. Each part of the process model contains a common modeling error. Now, let's find out what those errors are by using the Control Flow Analysis plugin. We invoke Control Flow Analysis from the context menu. In the Control Flow Analysis view, we can see that two errors are reported. Let's examine the first error. The error message says that there is a lack of synchronization exists in the fragment between the fork and the merge. We can find out where in our model the error is located by clicking on the color fragment icon. A lack of synchronization is an error where two or more parallel branches are not correctly synchronized in the process. It has the effect that all tasks following the insufficient synchronization are executed more often than intended. In our example, the fork opens up three parallel branches that are subsequently synchronized by a merge. The behavior of the merge is that every time one of the branches finishes execution, control flow is routed to the second half of the process. This means the second half of the process will be executed 3 times in total, which is obviously not the intended behavior. To correct this lack of synchronization, we should replace the merge with a join. We do not want to change the fork because we do want the 3 tasks of examining different aspects of the application to be conducted in parallel. To change the merge to a join, we use the toggle gateways transformation. First, let's decolor the fragment. Then we select the merge and apply the toggle gateways transformation. As you can see, the merge has been changed into a join. We save our changes and rerun Control Flow Analysis. Indeed, the lack of synchronization error is no longer being reported. A valuable feature of the toggle gateways transformation that is worth mentioning is that not only does the transformation allow you to correct errors caused by gateways, as you have already seen, it will also ensure that you do not transform a correct model into an incorrect one. Let's see how this works. Remember here that we have a fork paired with a join. Let us select the fork alone and apply toggle gateways again. Notice that the fork and the join have been changed into a decision and a merge, although we had only selected the fork. The reason toggle gateways behave like this is that when you toggle a gateway that is part of a fragment that contains an error, only the selected gateway is toggled. However, when you toggle a gateway that is already paired with a correctly matching gateway, the pair of matching gateways is always toggled simultaneously to ensure that you do not introduce a modeling error into your model. Now, let's examine what the second error is about. The error message says that there is a deadlock in the fragment between looks promising and the end of the process. A deadlock means control flow will stop at some task or gateway in the process while the task or gateway is waiting for some input, but the input will never arrive. To find out where the error is located, let's again click on the error message and highlight the fragment in error. The reject task waits for 3 control flow inputs from its incoming connections. However, in any single execution of the process, only one of the control flow inputs will arrive at the reject task because the 3 decision gateways always only activate one of their output branches. Consequently, the reject task will never receive all of the 3 control flow inputs it is waiting for, and therefore a deadlock will result. Now that we know where the error is, we can go ahead and fix it. Again, we decolor the fragment in error. To make it easier to correct the deadlock error, we will first make the error more explicit by applying the activity to gate waveform refactoring operation to the reject task. The activity to gate waveform refactoring operation translates the input and output logic of the task into the corresponding gateways. We select the task, and then we apply the activity to gate waveform refactoring operation. As you can see, the 3 incoming connections to the reject task has been replaced by a join with 3 incoming connections and a single outgoing connection leading to the reject task. The deadlock error is now obvious. The decisions have been paired with a join. Let's fix the error by toggling the join into a merge. We select the join and invoke toggle gateways transformation. Again, we save our changes and rerun control flow analysis. This time, the control flow analysis plugin is reporting no error. The deadlock error is gone. This concludes part C of the tutorial, where we have used control flow analysis to detect 2 common modeling errors, locate the errors, applied the activity to gate waveform refactoring operation to make the error more explicit, and finally fixed the errors by using the toggle gateways transformation.